Hi everybody, welcome to online video lectures. I am Dr. R. Vivekananda. I am Department of Mathematics and Management Sciences. Today, the course we are going to discuss here is Fourier and Complex Analysis. In this course, Unit 3, Integration Complex Functions and Power Series. In that Unit 3, topic is Integration of Complex Functions. Integration of complex functions we have already discussed. Some problems we covered. Some more types of problems I am going to discuss in this lecture video. Right. Continuity of a complex function. This I said in a previous class. That is, limit of a function equals to function value at that point. Then the function is said to be continuity of a complex function. Next, derivative. Derivative of a complex function. As similar, the derivative of complex function in real system. Similarly, the derivative of complex function we defined here. Okay. Next, analytic function. Analytic function f of z is said to be analytic function at a point z0 if f of z is differentiable at every point in the neighborhood of z0. That is what here. That is, f dash of z0 exists for all z. This is nothing but a neighborhood of z0. Neighborhood of z0. That neighborhood of z0 defined with radius of epsilon, where epsilon is greater than 0. Okay, so then f of z is said to be analytic at z0. So f of z is analytic at z0 means f dash of z0 exists, and in the neighborhood of z0 at every point f dash of z0 exists. Then the function is said to be analytic function. Singular point. Singular point means where the function ceases to be analytic. Ceases to be analytic, where the function ceases to be analytic. Means at some point, if the function ceases to be analytic is nothing but if the function derivative doesn't exist. If the function derivative doesn't exist, so that function is said to be, that point is said to be singular point. Statement, Cauchy's integral theorem. F of z equals to u of u plus iv be analytic within an on simple closed curve C. Let f dash of z be continuous there, then integration of f of z is going to be 0. Cauchy's integral theorem, what it says, if the function is analytic over the curve C, then integration of that function is going to be 0. The complex function is analytic on and within a simple closed curve C, and f dash of z exists and continues therein, then integration of f of z dz is going to be 0. That is what Cauchy's integral theorem. Next, Cauchy's integral formula means if there is no singular point exists and everywhere it is analytic, then the integration is going to be 0. If there is any singular point exists, Cauchy's integral formula we have to take. We have to take this formula. Means if there is only one singular point exists, then integration over C f of z by z minus a dz equals to 2 pi I into f of a. 2 pi a into f of a. This is the way of finding integration of a function where the singular point exists in the curve C. This is Cauchy's integral formula. Next, Cauchy's generalized Cauchy's integral formula means if there are more number of singular points, in that case the formula is integration over C f of z by z minus a whole power n plus 1 dz equals to 2 pi I by n factorial nth derivative of f at a. This is nothing but nth derivative. nth derivative. That is okay. Cauchy's generalized Cauchy's integral formula. If there are n plus 1 number of singular points, if there are n plus 1 number of singular points, that is z equals to a, z equals to a is happened n plus 1 times, then the evaluation of that function over the curve c equals to 2 pi I by n factorial into nth derivative of f at a. This is generalization of Cauchy's integral formula. Now verify Cauchy's integral theorem for the function. See, the given function here the given function f of z equals to 3z square plus iz minus 4 is a polynomial function. Polynomial function in Z. And we know that or we aware of that every polynomial function is analytic. Every polynomial function is analytic everywhere in the complex domain. Or complex field. Okay. If it is analytic and there is no singular points, then by Cauchy's integral theorem, Cauchy's integral theorem integration over c 3z square plus iz minus 4 into dz going to be 0. What Cauchy's integral theorem says? If the function is analytic everywhere over the region in the closed curve C, then its integration is going to be 0. That is what Cauchy's integral theorem says. So here the given function 3z square plus iz minus 4 is a polynomial function. For a polynomial function, there will not be any singular points. If there are no singular points means definitely it is analytic everywhere. If it is analytic everywhere, its integration is going to be 0 according to Cauchy's integral theorem. Right. Previously this sum I explained by taking the square its vertices along the lines, along the sides, evaluate integration and add them, that is going to be 0. In that way also you can do, that I have explained in previous video. In that way also you can do, otherwise you can do like this. If it is asked for long answer type questions, you do in that way, means the previous method. If it is short answers means like that you write. Even you can also write this answer for long answer, but you need to elaborate the reason and all. Elaborate the steps, whatever the steps I have given, that you need to elaborate in case of longer answer. Okay, in case of longer answer questions, you need to elaborate if you write this solution. Right. Okay. So for this question, I have discussed previously by taking the square along the sides of a square, evaluate integration along each side of a square, evaluate integration and add them, that is going to be 0. That is also a verification of Cauchy's integral theorem. Okay, the other way the method is this one. This is very shortest method. If it is asked for longer type questions for 10 or 7 or 8 marks or 10 marks question asked, means better you go the previous method. If not, you can even this also you can write for long answer type, but you should elaborate the solution. You should elaborate the solution, not simply write like this. Okay, explain the regions, explain polynomial function is analytic, the given function is analytic, the given function is polynomial function, so it becomes analytic in the everywhere in the complex field. So therefore, by write down Cauchy's integral theorem statement. So as per the statement, its integration is going to be 0, like that you elaborated it. Okay. Next, consider the region 1 less than equal to mod z less than equals to 2. If B is the positively oriented boundary of this region, then evaluate integration over B 1 by z square plus 1 by z square into z square plus 16 dz. Evaluate this integration. Evaluate this integration in this region. In this region. In this region, we have to evaluate the integration. First, let us see here the given integrand function. The given integrand function, the given function. Complex function. The given complex function, that is 1 by z square by z square plus 16. First, let us try to evaluate singular points. Singular points means where the function is going to be not differentiable. At which point the function is not differentiable. That is singular points. Means evaluate by equating. Evaluate the singular points by equating the denominator of the function to E0. So what is the denominator of the function here? Z square into z square plus 16. So you take z square into z square plus 16 is equal to 0. To evaluate singular points, I am taking this one. To evaluate singular points, I said singular point means where the function ceases its analyticity. Ceases its analyticity. Ceases its analyticity means where the function differentiability doesn't exist. So from this, z square into z square plus 16 is equal to 0 means z square is equal to 0. That implies z equals to 0. And other one is z square plus 16 is equal to 0. That implies z equals to plus or minus 4i. Plus or minus 4i. So these are the singular points. These singular points lie inside the region or outside the region, we have to check. So why we have to check whether lie inside or outside? Because if the singular points lie inside, you need to apply Cauchy's integral formula. If these singular points lie outside the region, then the given function is going to be analytic everywhere. Okay. So for that purpose, whether the function is completely analytic in the given region or not, you have to check by verifying the given singular points lie inside or not. Okay. Now, before that, you just have the region. First, have the region. Sketch the region here. Region name, we name it as B. So that region I'm just drawing here. That region. So Z equals to 1 less than or equals to Z less than or equals to 2 is nothing but mod Z actually. Mod Z is nothing but is a circle, is a concentric circles. Concentric circles. concentric circles with radii 1 comma 2 units, with radii 1 comma 2. So first with radii 1 I am taking one circle with radius 1. With radius 2 another circle I am taking. Okay, so here this is a circle with radius 2 units, and this is a circle with radius 1 unit. This is a circle with radius 1 unit. Okay, and this is the center of the concentric circles, that is origin. Origin is the center of the concentric circles. Now here the region is between the two circles. The region is that between the two circles. In these two circles we have to, in between the two circles the region exists now. In that region we have to evaluate the integration. Okay, means here z is varying from 1 to 2. Z is varying from 1 to 2. Here 1, here z is 1, here z is 2. Means here z is varying from 1 to 2. 1 to 2. Now let us check. Here z equals to 0. Here z becomes 0. Now our region is this shaded part. So this is the region represents B. This is the region represents for B. Now you check whether these points lie inside or outside. Z is equal to 0. Z is equal to 0. Z is equal to 0. The point Z is equal to singular points are there na, that is Z is equal to 0, Z equals to plus or minus 5. So the singular points Z equals to 0, comma Z equals to plus or minus 4i. Plus or minus 4i means 4 units. Mod Z equals to 4. So definitely it lies outside. Z is equal to 0 is also lie outside, or lie outside the region, outside the region. Outside the region B. Therefore the given function is analytic. So therefore the given function 1 by z square into z square plus 16 z square into z square plus 16 is analytic everywhere in the region P. So by Cauchy's integral theorem, by Cauchy's integral theorem, integration over B 1 by z square into z square plus 16 into dz, value is going to be 0. right? So this is what integration of 1 by z square into z square plus 16 into dz over the b. B is the a circle, concentric circle. It means annulus region is lie in between the two concentric circles of radii 1 comma 2. Okay, so this is the way of evaluating integration over the annulus region. Annulus region is nothing but this is said to be annulus region or the shaded portion. The annulus region means the region which lie between two concentric circles. Okay. Next one. B is the positively oriented boundary of the region between the circles mod z equals to 4 and the square with sides along the lines x equals to plus or minus 1 and y is equal to plus or minus 1. Then evaluate integration b z plus 2 by sine of z by 2 dz. This is another question. Even this also very important one, this type of model. Thing is here, first what is the integrand function you take? You identify the integrand function. For that integrand function, what are the singular points exist you identify. Then you sketch out the region. Sketch out the region B. And after that you check whether the singular points lie in that sketched region or not. Okay. First, I am taking integrand function here. Integrand function z plus 2 by. The given integrand function is z plus 2 by sine of z by 2. So for this singular points means where the function ceases its differentiability. Means when the denominator is 0, then differentiation is going to be, function is going to be undefined. Na? So singular points I am evaluating. So by singular points I am evaluating by equating sine of z by 2 equal to 0. Sine of z by 2 is equal to 0 means z by 2 should be equals to n pi. For n is equal to 1, 2 and so on, sine pi is 0, sine 2 pi is 0, sine 3 pi like that. So n pi, z by 2 is equal to n pi. I am taking here. N is equal to 1, 2 and so on. From this, z equals to plus or minus 2 n pi. When n is equal to that implies that is z equals to 2 pi plus or minus 2 pi plus or minus 4 pi because n is equal to 2. N is equal to 1 is 2 pi. N is equal to 2 is 4 pi. N is equals to 3 is 6 pi. N is equal to 4 is 8 pi. Likewise. So these are the singular points or singular points we evaluated or singular points. Now these singular points lie inside the region. First we evaluated singular points. Now you try to go for evaluating, sketch the graph, sketch the region. Okay. Now, so what is the boundary region? Mod z equals to 4 and the square sides with x equals to plus or minus 1 and y equals to plus or minus 1. So here boundary of the region B, the boundary of the region B, region B. Region B, mod z is equals to 4. The sides of the square, the sides of a square, x plus or minus 1, y plus or minus 1. Okay. The region means between, here mod z equals to 4 is a circle. Here mod z equals to 4 is a circle. Here mod z equals to 4 is a circle with the center at origin, of radius 4 units. Okay, means the region B between mod z equal to 4 and the sides of a square. Now let us take try to sketch the region. Here x is equal to 1, here x equals to minus 1, and here x equals to y equals to 1 and y equals to minus 1. Now sketch the graph. First square. So this is a square. Okay. This is a square. Of sides. This side is x is equal to 1. This side equals to x is equal to minus 1. And this is y equals to 1. And this is y equals to minus 1. Okay. Now we have to draw a circle of radius 4 units. So I am taking a radius of 4 units here. Circle I am just drawing of radius 4 units. Okay, of radius 4 units. So this is a circle of mod z equals to 4, and this is a square. Okay, now the region between circle and a square is the region between circle and radius, or a circle and a square, is this is the region. You have to sketch the region that is meant for 2 marks in the part of the solution, sketching the region also. If you sketch the region very carefully and neatly, you will get 2 marks for that. Okay, if you sketch the region properly, you shade the region between square and circle, so that's what I am shading only in between part. Okay, okay. So like this you shade the region. So this region is said to be B. This region named by B, this shaded region, shaded region, shaded region. Okay, now singular points, we identify the singular points as, now we identify the singular points as plus or minus 2 pi, plus or minus 4 pi, plus or minus 6 pi, and so on. Pi means how much? Pi means 3.14 something. 2 pi means it is going to be 6.14 something, above 6. But the region is from 1 to 4 na. Here the region is, here the region of limits, the limits for region is, the limits for region is 1 to 4. Z equals to 1 to Z equals to 4. Here Z equals to 4, here Z equals to 1. And here Z equals to 0. Okay. So, but the singular points lie outside the region clearly, because the bounded region is happened from Z equals to 1 to 4. But the singular points are 6 point something, above 6. So, definitely the singular points lie outside the region. So, from the observation, from the above observations, from the above observation, the singular points lie outside the region B, outside the bounded region B. That is, the given function is, analytic everywhere in the bounded region, Therefore, by Cauchy's integral theorem, its integration over the region, by Cauchy's integral theorem, integration over C, what is that? Z plus 2 by sine of Z by 2. Z plus 2 by sine of Z by 2 into dz is going to be 0 over B, not C, over B. Okay. This is what? First I identified the singular points. Then I sketched the region. In that region, singular points lie or outside, lie inside or outside. I checked. I observed that all singular points are lie outside. Therefore, the function is said to be analytic everywhere in the given region, in the given boundary region. So, by Cauchy's integral theorem, the integration is value going to be 0. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.